the week, so I need you to participate. But for me today, I don't have the earphones, so I might not hear you when you are speaking. So if you want to speak, just raise your hand. I have my phone over here. I'll see, then I'll listen from the phone because my laptop speakers are not working. So yes, so let's start. We're going to start with day one, what we learned from day one, day two, day three, yes, up to day four. It's like a recap. So let's start with the day one content. Maybe you can ask questions. So, okay, so we said if you want to learn Raspberry Pi Pico, which is your choice because we have different types of boards, microcontroller boards. We have Arduino. Actually, for beginners, it's recommended for you to start with Arduino Uno. Actually, Arduino Uno, it's a beginner-friendly board. So if you cannot learn Arduino Uno, maybe you want to, your background is in Python, you can go for MicroPython and learn Raspberry Pi Pico. So you can find all the details from the official documentation for Raspberry Pi Pico, which is raspberrypi.org, or you can say Raspberry Pi Getting Started. Then you're going to find the tutorial of getting started with Raspberry Pi. Actually, today's class will favor those who have not been attending since the day one, because we are just going to see what we learned, and maybe you can ask questions, and we call it a day. Maybe until next time when will schedule another course for maybe Raspberry Pi, but maybe in the next session we are going to do something to do with Arduino and maybe ESP32 and 8266 for IoT, Internet of Things. So if you have a question, I think you will raise your hand, because I told you I will not be able to hear you unless you raise your hand. So for that, let me just a minute. I'm trying to. Sorry guys, I accidentally closed the tab. Let me rejoin the meeting. Sorry, I accidentally closed that tab. Sorry, I accidentally closed the tab for the meeting. Sorry for that. Okay, what I was saying, it's if you want to learn Raspberry Pi Pico, you just need to head to this documentation. I think I can send this link to the meeting. Getting started with Raspberry Pi Pico. So with that, you'll be able to learn. The first code in any programming language is called Hello World. So also in Raspberry Pi, you have to write or to print Hello World. So if you successfully print Hello World, I think you will be good to go. You'll be able now to to know the structure of Raspberry Pi. Okay, the MicroPython and also the what the syntax which is used by Raspberry Pi. Okay, so next you need to learn some terminologies like the machine. These are called modules, whereby if you want to access the GPL pins, like the GPL 1, 2, 3, going forward, you just need to initialize these module. Also for time, you need to initialize the time module. So the next thing you need to know, you need to learn about the technical specification of your board, like how many volts is it tolerant, is tolerant of let's say 5 volts, 6 3.3. Actually Raspberry Pi Pico, unlike Arduino, it's 3.3 volts tolerant. So if you are connecting a sensor which is rated at 5 volts, uh, for many sensors are rated at 5 volts, I think now you need to use a transistor. So you need to have some knowledge about transistor and the transistor theory, how you can connect the transistor to achieve 5 volts, or maybe you can use an external 5 volts from the to power your modules. So I think having known that, you are good to go. Also you just need to know the difference between 0 and 1 and different types of signals. Then for the hardware, okay, we said in embedded systems the first code, it's called blink code. Welcome Jacqueline. It's called a blink code. So if you can blink the onboard LED, you will be good to go. I think you'll have to pin my screen. Everyone, you can pin my screen on your side. You can pin my screen, and maybe you can zoom for you to be able to see the whole content. Okay, so the compiler we are using, it's called Doni. So you need to install Doni. It's free for your operating system. If you are using Windows, Mac, or Linux, you need to install Doni. Doni IDE. Just a minute. Sorry about that. We said you can install this Doni IDE and learn about. Actually, we have different. Actually, we have around 5 different ways how we can blink LED. We can use this function to toggle LED on and off. Okay, then we need to know how to save our code. You can save your code on the computer, this computer, using the first option, this computer, or you can save your code to the MicroPython device. For instance, we are using the Raspberry Pi. You can save it to the Raspberry Pi Pico. Then, for you to save the code, you need to save it with the file extension of .py. .py, that is the file extension which will be recognized as a Python file actually. So we have other types of modules. This one is used for timings. Yes. Next, digital input output. Actually, this tutorial or this guide is usually very simple to follow and beginner friendly also. Actually, they explain the breadboard, so you must know how to use the breadboard. So if you want to thrive in this field, you must know how to use the breadboard. If you don't know how to use the breadboard, you will find some difficulties when you are adding more components to your system. Also, maybe if you don't know how to use the breadboard, you can even destroy your microcontroller or your modules which you are working with. So you need to be well conversant with that. Simple projects whereby you need to let's say you are operating the LED. Now you see the blink code is usually the basic code, the basic most code for beginners. But if you want to build any project, you have to build on top of that blink code. It's like 1 plus 1 equals to 2. Then calculus, probability, differentiation, all those mathematics, they are usually built on that basic foundation. So let's continue. Controlling the brightness of the LED. Actually, we didn't do that, but maybe you can do that yourself. Yes, you will find some different several projects which you can do. Also, the next thing you need to learn about the components or the electronic components. Electronic. For robotics, so you need to learn about electronic components for robotics. So the likes of sensors. What is a sensor? It's a crucial aspect of any robotic project. Is the ability for a robot to report back information about its environment or to automatically react. So a sensor will collect environmental report or data. Then after collecting it, it will send to the microcontroller. Then the microcontroller, according to the code which has been written and uploaded to that microcontroller, it will now do some tasks according to the code. So we have different types of sensors. We're going to see that. Even a potentiometer is type of a sensor actually. Okay. Also, you need to learn about actuator. So actually, actuator is a different, is the opposite of sensor, whereby the mechanical attributes of actuators such as speed, torque are dependent on the electronic attributes. Okay, actuators work by converting energy produced by an electric motor into torque, which then moves a mechanism. The control system of an actuator can be handled. Okay, actuators are, I told you the two main types of actuators are motors and relays. Also solenoid locks types of actuators. Also, you need to learn about capacitors. What is a capacitor? Why do we need to use a capacitor? Maybe to smoothen some the electrical signals. How to rectify from AC to DC. How to step down, how to use some simple components like 7805. Actually, you need to know what is 7805. Actually, it's a voltage regulator. uh, if you are given around 12 volts, you need to be able to step it down to around 5 volts using some mechanism like for example, we are going to use the 7805 because or maybe you want to operate the Raspberry Pi Pico in 3.3 volts. So which mechanism are we going to use? So we are going to use the 7803, not 05, because the output here will be 5 volts and the input can range from 0 to 35, but the output will now be uh, 5 volts. Actually, these 0.22 microfarad capacitor and 0.1 microfarad capacitor, they are used to smoothen uh, the the power or the voltage uh, because of the okay, it will be smoothened by those two capacitors. Actually, they are the same capacitors which are used, but okay, but different value, which are used in the rectification circuit. So rectifier circuit. So let's see. These are rectifier circuit. Let me open this one. You can see it has a capacitor here in the output for it to smoothen the output, but also you can even ignore the capacitor, or you can omit the capacitor, but your voltage output will not be smooth, it will fluctuate. But it's good for you to practice the okay. Also, we have these rectifier, but here we have DC. Actually, this is a transformer. This is the symbol for transformer, or yeah, it's a symbol for transformer. Actually, by the look of it, we can say this is a step down transformer because the secondary coil is larger than sorry, the primary coil is larger than the secondary coil, so it's stepping down AC supply. Okay, it's stepping down. Then we have circuit, which are diodes. Actually, from here up to here and here, we get AC. This is totally AC, which has been stepped down, but the output is now DC. As you can see, we get positive here. I'm not sure if you can see. Let me open the image. So from this point, we are going to get positive because this point, this what is it called, diode. This side of the diode is actually the cathode, and this other one is actually the cathode. So the cathode will only okay. Okay, the other side is anode, and this is anode. It will be forward biased, so they will only allow positive electrons to pass, or yeah, to pass. So we are going to get positive here, and the other side we are going to get negative. Is there any question? Oh, sorry, I think my 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 camera is blocking. So let me just a minute. I even don't need, I think we don't need the camera. Okay. So let's continue. You can control LED with analog input, like for example, analog input. We have digital sensors and analog sensors. Actually, the as you can see, the ADC, it's usually called analog digital converter. We have that function for converting analog to digital. We have ADC pins in the Raspberry Pi Pico. Like for example, let me open the Raspberry Pi Pico, spin out. So you need to understand well this diagram. So with this diagram, we can see which pin. We can see, I think, pin number 26. It's ADC, analog to digital converter. So there you can connect your sensor, which is analog sensor. Also pin number 27, it's also ADC 1, ADC 0. We have ADC 2 here. Every pin has its special functionality. Also we can see in pin number 31, it's SDA, and pin 32 is SCL. It's a clock serial clock, and this is serial data pin. Also we have several of them. These are types of connections. Also we have UARTO, RX and TX. So if you want to connect, let's say it's a GSM module, maybe you are building a project whereby you need to send some SMS from the Raspberry Pi Pico, you need to connect using these two pins. Also we have several of them because I told you this board is usually very powerful. We have this pin number 3, pin number 8, pin number 13, pin number 18, 23, 28, 33, and 38. Actually all these pins are grounds. How many are they in total? One. Actually there are 4. Unlike for Arduino it has not 4. Are they 4? They are 8. 4 times 2. Arduino usually has only 3 3 ground pins. Okay, then it has the 3.3 volts output. What else should you not? Okay, as you noticed, the Raspberry Pi Pico doesn't have a reset button. Actually, this button can never reset your code. Unlike for Arduino it has a reset button. So what do you do if you want to reset your board? You just need to make your own reset button by connecting the ground to pin number 30. You can see pin number 30, it has no other functionality. Actually you cannot use pin number 30 as it's not a GPIO pin, so it's called run. It is given it is assigned to this functionality for running. So for resetting, so you just need to pull if you want to reset your board, you just need to pull this pin low or down by just connecting it to any ground, any of the 8 grounds. Okay, anything else? So if the pin is high, it means your code will or your Raspberry Pi Pico will run normally. Okay, these are on-board button. It's only for entering between or selecting some modes, programmer mode and normal mode. So if you press and hold this button and connect your board, it will appear as a storage, external storage device. Then you can either prepare it to run on MicroPython or what or Circuit Python. Yes, Circuit Python. Is there any question up to there? Software there, power your Raspberry Pi Pico. What next? What do you need to do next? Introduction to Raspberry Pi Path. We have some documentation. Actually, I'm going to send you the book. Let me share the entire screen. I want to send the book. I have a Raspberry Pi book. Sorry, I think this one. Getting started with Raspberry Pi. I'm going to share this book. Actually, you can also Google it. Yes. So, you need to minimize my screen or to zoom using your two fingers for you to be able to see everything if you are using your phone, but if you are using your computer, you're good to go. Okay, so this book will give you a detailed guide on how to set up your Raspberry Pi Pico, get to know the Raspberry Pi Pico, how to attach the pin headers, install MicroPython and to programming with MicroPython. So let's jump to this chapter, how to, okay, table of contents. Physical computing with the Raspberry Pi Pico, traffic light control, reaction. All these are projects. Actually, from chapter 5, you're going to build some projects. We have data logger, maybe using another sensor like DHT11. You can design your data logger. Digital communication protocols, I2C and SPI. Actually, SPI is usually used by NFC or RFID, radio frequency identification. I think you know the RFID cards. I2C for what is it called? LCD display. Yes. Okay. Let's try some project. Let's say chapter number 5, traffic light controller. Actually, we did this project. You can also try it. Warning: always remember that an LED needs a current limiting resistor before it can be connected to your Pico. So before you connect your LED, any LED, make sure you use a current limit. Actually, it's a resistor, just a resistor, but now that resistor will be given a name, a current limiting resistor. Actually, it will protect the LED from burning out. So use a current. As you can see here, we get 1, 2, 3 because we have 3 LEDs. The best outcome is the LED will burn out and no longer work. And that is the only best outcome. It's ironic. The worst outcome, it could do the same to your Pico. Oh, the Pico can also burn out, but I don't think so. It's a rare scenario, scenario. So for me, I usually connect it direct, but don't do that. import time. These are the codes. Also, you can add a buzzer. Actually, we did that. We added a buzzer to our setup for maybe for audio, to make the program or the project to be audio visual, like you can hear and you can see what's happening. Challenge, maybe you will be getting some challenges and need to address you can in fact you can design a reaction game. Yes, very simple. So I think we are good now. Told you our class today will be so short. So let me close this one. I'm going to share the. Also, you can just search "Getting Started with the Raspberry Pi Pico PDF" on your browsers, and you will get the book. It's free. So let me just show you something. Also, if you head to YouTube, you can learn more about Raspberry Pi. Like just say Raspberry Pi Pico projects. We're going to get a number of some projects which they are beginner friendly. Like we have these 10 cool projects powered by Raspberry Pi Pico, 11 new Raspberry Pi Pico W. Actually, I'm going to advance to Raspberry Pi Pico W projects. Okay. Yes, how to display some text using Raspberry Pi Pico. That was the LCD. Now this is using OLED display. This one. There's even a Kenyan channel. He is my friend. He usually does some videos on Raspberry Pi Pico. Dominic, 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 Dominic. So actually, you can follow this channel. You can subscribe actually. This channel is a Kenyan. He's my friend. He usually posts some Raspberry Pi Pico. You can see Raspberry Pi Pico mobile M-Pesa lights control. If you send some money using your mobile, as you can see, this one was posted 10 hours ago. You can control your lights using STK push on M-Pesa. If you pay 10 bob, maybe it will turn on the lights. Lipa na M-Pesa, a lot of projects actually. So make sure you follow this channel, you subscribe to that channel. Anything else? I think with that I'm done for today's class, unless we have any question. Do you have any question? If you have any question, you can unmute and so. So, uh, what's happening? Okay. So, so if you have any question, I think you can unmute and ask. Any question, any comment, any question, any comment, or any contribution. Then before we leave, I just need your favor. I just a minute. Let me do something here. How was the session? Someone should unmute and say how was the session from day one up to today.
Good evening, everyone.
Good evening.
For those who don't know, I'm Karaoke Evans, and we have been doing this presentation with Fred. Yeah, I'm the lead of IoT and robotics in the University of Embu. And I thought it would be nice for this last session, like we take some minutes for introduction at least. Maybe I'm in the same institution with somebody who was in this session, and maybe we can help each other baadaye. Unaona, maybe mwingine ako JKUAT ako na wish yake from these sessions, and maybe the day they missed and they would want to be helped out. Yeah, so some introduction favor, that is my idea. But overall, I'm so much grateful for the sessions that you offered your time. You're so much. Yeah. So,
First of all, let me say I have missed a lot, but I am grateful for the whole week. Like I have learned a lot. Robotics is something I've wanted to go into for a long time, and it's a good starting place. So I thank you so much, Fred, for everything you have taught us so far. I will definitely look into those resources that you've given us. About the introductions, I am currently a student at Moringa and ALX, so I want to now go into robotics. But yeah, thank you so much for all the lessons and giving us your time.
You're welcome. Next. Jacqueline. Should I mention names? Elizabeth. NW.
I'm the one who just talked.
Oh, sorry. Elizabeth and W, or anyone else to. So there's a feedback form which I'm trying to compile here. I'm going to send to share the link. Then you can help me to get some feedback. Anyone else?
Same some of us kinda the introduction ni kind of wakalia, I don't know. Ama I don't know, they are not with us. Unajua leo tena ni Friday, maybe watu wako sherehe. Watu hapo wamemute mic, I don't know. Yeah, so I have a question.
Mm.
Yeah, I got a project yenye nilikuwa nataka kufanya IoT and I wanted to integrate AI in HEMS, the Home Energy Management System.
Mm.
And ndo najaribu kufikiria kama nitaanza kufanya research. I'm still lazy kidogo. I'm not sure the direction to take. I don't know whether to use ESP32 ama 80 watt. Yeah, I'm not sure which will be the best for that project. And maybe any leads from our facilitator can be appreciated.
Oh, unataka, how do you want it to operate?
From my perspective ilikuwa hivi, si unaona HEMS usually drainage ama niambia this is the time this should be off, this is the time this should be on. Yeah, so from my perspective I was to train the AI model from a certain data, so inachukulia like hii sensor ikiipea like ikiipea signal like this week darkness inaingia hii masaa, so it will be able to shift ikuwe na pattern yake. Maybe kaa ni I'm assuming nikitumia LED saa itakuwa ina represent kitu kaa let's say television, fridge, nini vitu kama hizo. So some things I'll have trained them that hii kitu haifai kupitisha masaa sijui ngapi, like inafaa kutuma this and this and this. So at the end of the day AI will be itakuwa inafikiria, inaona huu mtu ametumia this gadget for this long, so for today it should be off. Ama in fridge sahi haihitajiki kukuwa on and it's using electricity, let's switch it off. Ama inafikiria let's switch from DC to AC, maybe uko na solar panels, saa zingine inafanya that switching.
For that, I think juu iko na ni machine learning, and now machine learning inakuwa ni si kitu rahisi hivi. What you can do, actually there's a platform called Edge Impulse. I think I mentioned this in my first classes, my sessions. You can search about Edge Impulse, and in fact in Edge Impulse you can use some boards like Arduino Nano. There's a board called Arduino Nano 33BLE, which you can use it to train your models. It's very simple. Actually, it's like Scratch, when you drag and drop. You can use it to train your model, machine learning model. So, and also you can add more sensors on your system, on your setup. So maybe you can try and see kama hiyo itakusaidia, but it's a challenging project, so you need to do a lot of research.
I'll do so much on that because the end of it nataka kumecha nayo. I'm an IT student by the way.
Eh?
I'm an IT student by the way.
IT.
Yeah.
Oh, nice. Also now in this field of robotics and actually it's usually robotics and IoT. So there is a way we can even collaborate now to IT. to build some hardware. You see, like for example, there's a video which I did about home automation. It's a system which you
Yeah.
can control your lights, any electronic device from anywhere in the
Yeah.
world. Now you see we have that part for web ama IT. So kama siko sawa hapo, you can
Yeah.
you can collaborate with someone mwenye ameiva IoT, because you can design a system with like web servers. Maybe you can do research on web servers. Web servers iko na hardware na ziko na the software part whereby it's integrated. Actually, it's coded in what in HTML, CSS and JavaScript, and now we have the hardware. You see, watu wengine wanakuanga poa kwa software, yuko sawa hardware. Now you can integrate. Sasa kama wewe uko kwa IT, I think you are good placed. Ni kusoma tu electronics kiasi kiasi, then you'll be good to go.
Yeah, actually I had this knowledge ni vile sikuwa na that direction yenye niko fixed yenye nataka kufollow, but for now at least I've made that decision. Yeah, and it's something that ni research tu nafaa kufanya hiyo proposal ndo sasa nianze prac yenyewe.
Oh, nice. Iko fit kabisa. So I think
Yeah,
I can stop the recording